So to continue, number 17, we've got if 3xy equals 1/9, 2x plus y equals 0, and x is positive, then x plus y equals blank. Now this problem might look tricky, but let's start with writing 3xy equals 1/9. The only way to get 1/9 is if my exponent is positive. We know that if we square 3, we get a positive 9, but if we raise it to a negative power, we end up with negative. With a negative power, we end up with a fraction of 1/9. So we should know right here that x times y equals -2, because that's the only way we're going to get a 1/9 in the denominator. We also have the equation 2x plus y equals 0. I'm going to solve for y by subtracting 2x. So I know that y equals -2x. So with my system, I'm going to take the y value and plug it in up here. So x times -2x equals -2. Well, this gives us -2x squared equals -2. When I divide by -2, I get x squared equals 1, so x is equal to 1. To find out the value of y, I'm going to go ahead and just plug it into this first piece, or this part right here. Y equals -2 times 1, so y is equal to -2. And in order to do this problem, I did have to know that 3 squared was 9, so in order to get a fraction, I have to raise it to a negative exponent. To get x plus y, that's the same as 1 plus -2, which is -1, which is answer B. Continuing on to number 18, almost done here. Remember, these problems are a great review for your test. Number 18, the product of a and a minus 1 is 6. Which is the possible value of a? So product means multiply, so I'm going to distribute. This times this is going to be a squared minus a. And when I multiply that, it's going to equal 6. Well, this looks oddly familiar, like a factoring problem. So I'm going to subtract over. I'm going to get a squared minus a minus 6 equals 0. So this is factoring. Looking for two numbers that multiply to -6 and add to equal -1. Those numbers are 2 and 3. In order to add to get a -1, that means the 3 has to be negative. So I'm going to bring this back up here. A plus 2 times a minus 3 equals 0. So a is equal to -2 and positive 3. That answer choice is C. Again, if you got it here, you could always graph it and it would tell you. The sum of two consecutive integers is 256. What is the value of the larger integer? Anytime you're dealing with integers, you want to start off with just x. That is the first one. So let's assume that this is 1. The next odd integer is 3. Well, starting at x, I must add 2 to 1 to get to 3. So x and x plus 2 are your consecutive odd integers. Now, if I add those consecutive odd integers, x plus 2, they have to equal 256. Well, combining those like terms of x, subtracting the 2, and then dividing, I get 129. So what is the value of the larger integer? Okay, what is the value of the larger integer? Let's see here. So what I'm going to do, oh, I'm sorry, this is a 7, 127. Sorry about that. Now, 127 is an answer. However, I want the larger integer. So what that means is if this is 127, the next consecutive odd, I add 2 to get 129, which is option C. That's my fault. That should be a 127. All right, the product of two numbers is 20 and their sum is 12. What is the difference between those two numbers? What I would recommend is just doing a guess and check. Okay. So the product of the two numbers is 20. So I'm looking for two numbers that multiply to 20, and those same two numbers must add to 12. This is basically the logistics of factoring. Remember, we talked about factoring. So 10 times 2 can give me 20, and 10 plus 2 can also give me 12. So the difference between 10 minus 2 is 8. So this is kind of like a hidden factoring problem. You have to understand the basics of factoring in order to do number 20. All right, for the positive value of m over the square root of m is equivalent to blank. Well, I can rationalize variables. So I don't want the square root in the bottom. I want it to be in the top. M times the square root of m is m square root of m. Square root of m times square root of m is square root of m squared, or m. The m's should cancel, leaving me with the square root of m, which is option D. Which of the following I'm getting all tongue-tied up here. Which of the following is equivalent to the expression 1 minus x squared over x for all non-zero values? So anytime you have a piece like this, adding and subtracting, you can always break up your equation to look like this. Because combining those, I would get the same answer. I should be able to see that I have x squared on top and x on the bottom, which means one of the x's will cancel, and I'll just be left with a positive x up top. This matches option C. So all I did here was kind of piece apart the fraction, and then from the piecing apart, I simplified right here to get x. Number 23. If negative k squared equals k, which of the following is a possible value of k? So negative k squared equals k. I'm going to go ahead and make that equal 0. So negative k squared minus k equals 0. So I will pull out a GCF of k, or negative k in this case. And I'll be left with k plus 1 equals 0. Well, negative k equals 0, so k is 0. K plus 1 also equals 0, so k equals negative 1. And that answer is D. Anytime you're dealing with k squared and k's, think of GCFs and bringing everything over to one side, and then you're good to go. So pulling out GCF. X is greater than 0. Which of the following will have the smallest value? So you can honestly do pretty much whatever you want to, or use a little common sense here. If x is greater than 0, I'm looking for which one has the smallest value. A positive over a positive is a positive. A positive squared is a positive. Positive over a positive is positive. And a positive raised to the third is a positive. However, right here, a positive times a negative will always be a negative, making A the correct answer. You could also do this. Let's make x equal to 1. I would get negative 2, 1/2, 1, 1/4, and 1. Well, the smallest is negative 2. So you could use just thinking through it, or you could actually plug in a value. All right, the number x can be written in the form of k squared minus 2 for some integer value of k, which is the value of expression of x squared. So in this problem, it says that x can be written as k squared minus 2, which means x equals k squared minus 2. Okay, we're looking for which value is represented when x is squared. Well, when x is squared, we're going to have k squared minus 2 times k squared minus 2. This problem is basically you building an equation as you go. So now I'm going to distribute. K squared times k squared is k to the 4th minus 2k squared minus 2k squared plus 4. All I did was distribute. Combining, I know right here that I'm going to get a negative 4k squared. So k squared minus 4k squared plus 4 is option E. So all I did here was substitute and build my equation as I went. Number 26, which value would be true for any possible value of x? So what I'm going to do is go ahead and solve. I'm going to get the x's together. So if I subtract x from both sides, I get negative y is greater than positive y. Well, the only way that I can get a negative y greater than a regular old y, this is only true. Okay, this is only true when y is less than 0, which is negative. The only way that, let's say that y is equal, let's make it negative 2. Negative 2 has to be greater than negative 2, which is basically positive 2 is greater than negative 2. So the only way for me to have a negative here and it be positive, then a value over here is whenever I plug in a negative, because the double negative will make it positive. Option C. Which of the value of A is a solution for the inequality? A minus x is greater than or equal to C, but is not a solution to A minus x is greater than C. So you're looking for which one is a solution where it's greater than or equal to. Okay. So for this problem, you're looking for which one is not true here, but is true here. Or, excuse me, is true here, but not true here. Well, the only difference is that up here, A minus x can be equal to C. That's the only difference between these two. So if it's a solution of this one, but not a solution down here, that means that A minus x has to equal C. So A equals C plus x, which is option D. The only overlap here is that this one is including when they can be equal, and this one is not. Number 28, if the smallest of three consecutive integers is x, which of the following expressions represent their sum? Well, if I want consecutive integers, that would be like x, x plus 1, x plus 2. And I want to know their sum, so I'm going to go ahead and add all of those together. So x plus x plus x is 3x. 1 plus 2 is 3. Option D.